real quick, when we're looking at transformations of any kind of function, and in particular, I want to look at maybe a quadratic one here in a second, because that's kind of a little harder one. And then there's number 5 on the last assignment. I don't want to give you too much help on it, because I want you to think about it, but maybe we'll talk a little bit about it. This reminds us of everything, this represents all the possible tweaks we could do to a function, right? If you look at the constants up here, a, b, h, and k, the values of those parameters would execute all of the kinds of tweaks we talked about. We could shift horizontally, shift vertically, stretch vertically, stretch or shrink vertically, stretch or shrink horizontally, and then we could reflect, right? We could reflect over either the x-axis or the y-axis. Okay, so let's just deal with these one at a time. Which of those parameters up there is going to control how far we shift a graph horizontally? H is, right? The number that's being subtracted from x tells us how far we're shifting the function left or right. If h is positive, we're shifting it to the right. Negative, we're shifting it to the left. Which one of those parameters controls how far we're shifting the graph up or down? K does, right. The number we add to the end. Positive goes up, negative goes down, right? Okay, which one of those parameters up there tells us how much we're stretching or shrinking a graph vertically? A does, right? So if A is, for example, 3, then we're going to stretch every point up by a factor of 3. How would we shrink it vertically? 1/3. 1/3, right? We're going to make every y value 1/3 as big as it was previously, so we compress it vertically. Which number, and this is probably the trickiest, which number up there is going to predict how much we're stretching or shrinking horizontally?
B.
B. And remember that this is kind of the weird one, right? I like the way our book does this. They write it as 1 over b, so then values of b that are bigger than 1, like if b was 10, then we'd multiply the x value by 1/10. That means that we're going to stretch it, right? So b acts just like a does, but for horizontal stretching or shrinking compared to vertical stretching or shrinking, right? Does that make sense? So I want you to tell me then, don't say it out loud here, everybody just take a look at this for a second. What are we doing to this function? So if f of x is, it doesn't matter what it is, we'll say it's x squared. What are we doing down here? How many different kinds, maybe I forgot one other thing here too, while we're at it. The sign of which of those parameters tells us whether the function has been reflected over the x-axis. A, right? Everybody agree? If A is negative, that means that we're just going to have an opposite y value, which means that it's been reflected over the x-axis, right? Okay, what happens if B is negative? Reflected over the y-axis, right? Okay, so now there's a lot of stuff being done right there. What are the things that are being done? Somebody tell me one thing that's being done to that function. Yes?
Shifting it down 4.
Okay, it's being vertically shifted down 4. Joe, what else?
It's reflecting over the x-axis.
Okay, it's being reflected over the x-axis. Good. 2. What else? So what if we, and let's see, what have we accounted for then? We can almost kind of cross them off. So the down 4 is right there, right? The reflection part was right there. That's the negative sign. Tyler, give me something else.
Vertically stretched by factor.
Okay, it's being vertically stretched by a factor of 3 because of that 3 right there. So what else? One other thing. Yes?
It's going right 2.
It's going to the right by 2 because of the 2 right there. Does that make sense? Okay. One other thing. So if f of x is x squared, what if we didn't write this in terms of f of x? What if we wanted to write out g of x as an actual function? What would that look like then? So I've got my -3 out front, but what is f of x minus 2? Now this is something I feel like maybe people are having a little bit of an issue with this. If f of x is x squared, what's f of 2? Okay, how'd you get that? 2 squared. What's f of a million? A million squared. What's f of a? A squared. What's f of the quantity x minus 2? Quantity x minus 2 squared, right? So this part right here then, everybody see that this part, the f of x minus 2, is just going to become the quantity x minus 2 squared, right? And then minus 4 at the end. Okay, so that's the function that g of x actually is then, right? Based on our parent function, if f of x is x squared, then this is g of x, right? Because f of x minus 2 must be x minus 2 quantity squared, right? Okay. So this comes, I picked something that's right out of your, what is it? This is the lesson under student resources. It's the 1.3 lesson. So you don't need to write anything, it's right there. I mean, just go to that if you want it. This is just an example that's in there. And this is what you already told me, right? This is all the stuff you told me. Okay, let's try something. I think I'm done with that. Just make sure. Yeah, so if we wanted to graph this thing, doesn't this make sense then? These are all the things you told me, reflected over the x-axis. It was shifted vertically down by 4. It was shifted horizontally by 2, and it was stretched by a factor of 3. Right? That's all the stuff you told me, right? And we started off with just a plain old y equals x squared graph, which would have looked like that. Right, f of x equals x squared, okay? Okay, let's look at something, oh, already looked at that. How about something like this? Okay, so an old stone bridge over a river uses a parabolic arch for support. In the illustration shown, the unit of measurement for both axes is feet, and the vertex of the arch is at point C, and they're giving us the coordinates of C, right? Find a quadratic function that models the arch and state the function's domain. Okay, so what function are we going, what's our parent function going to be? What's the basic function we're going to start with and then tweak it to get that? X squared. Does that make sense? Okay, so we'll start with the parent function, call it f of x. F of x equals x squared, right? Now you see if you can tell me what's our function of our graph of g of x. Let's write it generically with all the possible tweaks. Okay, so g of x, which is this new function down here. What are all the possible tweaks I can do to f of x? Okay, so I've got an a that's going to be out front, right? That's going to control the vertical stretch and reflection over the x-axis, vertical reflection and stretch, right? Times f of what? Okay, 1 over b. So I've got my 1 over b times x minus all we're doing is looking at that, right? X minus, I don't want an exact value, just in general. X minus, what letter do we put there? H, okay? And then, oops, I'm gonna close that. And then finally plus k. And so we've got to figure out what are the values of those 4 parameters that are going to turn our basic parabola, which just starts here. It's gonna be a little difficult. So it goes kind of like that, right? Turn it into that. Okay, make sense? Okay, so what are some things we have to do? Okay, we got reflected over the x-axis, so a has got to be negative, right? So we know the value a equals negative something. Okay, negative what? Now let's look at this graph. So this graph it's centered at 27, -5, right? If I just reflect it over the x-axis, it's gonna open up down. But this one is clearly, something else has been going on here, right? This one it's been stretched, it's been tweaked, okay? How? How has it been tweaked? It looks like it's going through, what if I took this graph and I unshifted it? Because it's been shifted, hasn't it? We agree? What are the shifts, by the way? We'll just take care of those real quick. What's the value of h? Which one's h? What does h do? It controls left and right. So how far has it been shifted horizontally? 27 to the right. So what's the value of h then? Positive 27. Okay, how far has it been shifted vertically? -5, so what's k? -5, right? It's going down. Okay, would you agree? Okay, if we undo those, what does this graph look like? If we undo those, if we shift it back over here and back up to there, right? What's it look like? And let's go ahead and even unreflect it for a second. We just want to figure out, we want to know what's the magnitude of A though, right? How much has this thing been stretched? Everybody agree?
Yeah.
If we did that, doesn't this thing just look like the vertex is going to be there? Where is this point going to be? If I shift it up to there, so this point is essentially just going to there, and then we're just going to rotate, we're going to reflect it back up. We're going to unreflect it, so it's still opening up. Okay, good. So everybody agree that this point is 25 to the left of that one? Because this is at 27, that x value is 27, and that value is 2, right? So we got a point, we'll just call it right there, right, with coordinates -25. What about over here? 25, right? Isn't 52 25 more than 27? So we got this other point over here at positive 25. What about the y value? What's it going to be? Positive 15 in both cases, right? If this thing is reflected back up, isn't -5 15 away from -20, right? Okay, so now the question to you is, how are we going to, or the parent function looks like this, right? The parent function goes through, what points do we know the parent function goes through? 1, 1. Right, so what have we done to this thing? How do we get from the blue to the red?
Stretched it horizontally.
Okay, we stretched it horizontally. We can stretch it horizontally. We can really do both, couldn't we? To make the blue one, to make these points end up there, what did we do? Didn't we stretch them out this way and then stretch them up? Does that make sense? Right? So what's the amount of the vertical stretch? Vertically, we want to go, this is not drawn to scale, obviously, right? Vertically, we want to stretch these points from a y value of 1 up to a y value of what? 15, right? So what's my vertical stretch? 15, does that make sense? Okay, and it's been reflected, so it's negative, right? Everybody buy that? Okay. How much are we stretching it horizontally? By 25, right? So then what's the value of b? So 1 over 25, right? Everybody see that? Okay. Well, so B equals 25, but we got 1 over B in ours. Does that make sense? Okay. Oh. I'll tell you what, we'll finish this one up tomorrow. I'll give you an extra day on those. Sound good? Are you kind of getting the idea of how we can accomplish this though? Right? Okay, we'll finish this one up. We'll do one more tomorrow.
After, because I'm gonna write it down.
Yeah.